Hey guys, good morning. How are you doing today? I hope you can hear me loud and clear. Can you give me a quick confirmation? Good morning. Yes. Okay, thank you. Thank you. Okay. So now I was yesterday talking about the web access firewall. Okay. Now we have already seen it. What is web access firewall? Oh, sorry. Um, yeah, guard duty. So can you tell me what is AWS guard duty? We have discussed it. What is guard duty? Can you tell me? So when I talk about AWS guard duty, okay, what it was doing was basically it's being used, okay, to protect our infrastructure. Okay, so guard duty provides robust protection against some attacks. Okay, and it will ensure that if something goes wrong, the findings can be seen easily, and even it can suppress the attacks as well. Okay, now we can in the guard duty we can automate the finding response as well. So if you go to the guard duty here, okay, so when you open the guard duty, okay, there is an option which will come up which says enable the guard duty. In my case, I have enabled it yesterday because it takes some time to find some data. So I have enabled it yesterday itself, like in the night, yesterday night. And since all the resources are being deleted in this particular account in this region, I've never used this region. So it is able to find only one of the findings as of now. And let's see that finding, what exactly happened. It automatically find it. You don't have to do anything. As soon as you enable it, guard duty will be finding it. You get 30 days for free. After that, it will be charging you. So we will suspend it after 30 days. So here, if you click on the view all findings, you will see there's a low severity finding which is there. It says we have root credential usage. So we are using, someone is using the root credentials. Otherwise, there is no as such attacks which is happening up on an infrastructure. So it has not given us any output as such. But yes, you will see it gave me my this internet ID also. I'm using Readinet internet, so it's giving me that ID as well. Okay. Location also it has given me. It has given me my IP address also. When it was last seen. All these things. The user type is root type. So I'm using the access keys of the root type. I might have used some access keys of the root type, and it has given me that particular output here. Now, if it is not being used by me, I will immediately get that information that, okay, this is used by someone else and need to be taken care of. You are understanding it right? Please give me a quick confirmation. Now, similarly, if you see, we do have multiple protections can be enabled, wherein I can do EC2 malware scans. So if you have any machine, you can click on this start a new on-demand scan and you can put an ARN. You want to, let's say there is some production machine running up. You want to do a scan on that machine. You want to see if something is going wrong or not. So you can do a scan on the machine by putting an ARN. So I will just show you. If I go to EC2, I will go to the instances. See, this is the machine which is there. This is here you will see that ARN. When you scroll down, here the ARN would be there. You can simply copy this ARN. This is the machine which I have used yesterday. There is nothing inside the machine, so it's not able to find any issues altogether. Just put that ARN and confirm it. It can also do a manual checks for you, and this is one of the checks which I have done. I can export it to JSON format as well. Okay. And can easily see this stuff here as well. Now, S3 protection is enabled. You see, it is enabling or it is checking the S3 for me. Okay, so if there is some issues happening with my S3 buckets, which is present in the North Virginia, it will immediately tell me that this is a problem which is being identified in your S3 bucket. Then there is the EKS protection, which is there. Now, what is an EKS? It's a Kubernetes service. It's a Elastic Kubernetes service, EKS. EKS is Elastic Kubernetes Services. Now, what is the Elastic Kubernetes Services? Basically, it's a concept of DevOps. This is a concept of AWS DevOps, wherein, see, what happens is in DevOps, whenever we want to deploy any application, okay, so I will just give a very brief example. Let's say you are working for a company. Let's suppose any company, let's say Accenture. Okay, and your client is Netflix. So you're working for Accenture company and your client is Netflix. Now, there's a developer who is there working in Accenture. You are developing application on Netflix. So this is a Accenture testing server or pre-production server where you will upload before giving it to the Netflix production server. So you will upload your application in this testing server where the Netflix application in the testing server. Everything you will install, whatever dependencies this application needs to run. Whatever dependencies this application will need to run, you will install it. Just give me 1 minute. Sorry. Okay, so here all the dependencies you are going to install it because this application needs some dependencies to run. Every application needs some dependencies to run. So when you install those dependencies, okay, since the developer is working on this machine, Developer will install all these dependencies with the application. Netflix will now come and check it out whether it meets the requirement or not. Netflix will say, okay, it's good. We can go ahead with it. So you gave this application to Netflix. But the problem is these dependencies are not present in Netflix, and Netflix cannot install the dependencies without the leadership permissions also. Now, what do you think is the solution here? You're getting the problem statement, guys. Are you understanding the problem statement here? Have you understood this? This is the DevOps part, but yeah, I'm just giving an overview here. Okay. So this, what we can do is if we can package this application in a container, if we can put this application in a container with all the dependencies and we deploy this container here. We deploy this container here. So what we do, if we can package this application, if we can package the application in a container and deploy the container to the production server, production is this server. Now it does not matter if these dependencies are present in the machine or not. So we have a container in which the application is running up, and we can have multiple such containers with different applications running up in the same machine. Basically, this containerization is done by a software known as Dockers. And okay, and the concept in AWS is known as ECS. And EKS is, it manages those containers. It's a container management tool. It's a container management process. Process is there. EKS is there. So it's not there in your curriculum, but yes, basically this is what happens when you have to go ahead and learn DevOps also, guys. It's really important. DevOps and AWS is a very deadly combination. You will really see that you are getting a very high packages after that. I will give you the structure. If you do not want to take any course, then after 5-15 days only start with DevOps. Okay, not just today. Just get this AWS done and then start with DevOps. That is sufficient. Now, now we have malware protection of EC2. Now, this malware protection, we have already seen it here. Okay, this is the malware protection, which is an automated process. But here I can do it manually as well. But you will see that if you're doing it manually, it is not included in 30 days free trial. Okay, it's not included in 30 days free trial period. So if you want to join, or sorry, if you want to get that malware scan done, you can do it easily. You can do it easily with a 30-day, you can do it here by putting your EC2 ARN But yes, it's not in the paid period. It will be paid basically. It's not free, so it will be paid. That need to be taken care of. Now, the third thing, RDS protection, we can have the RDS protection also, which is there. Lambda protection is also there. All these things you will find it. Let me just do some here. If I go to the settings, yeah, I am just generating some sample findings. So I've just gone to the settings and I'm just generating some sample findings which the guard duty will generate, just sample findings for us to understand how does the sample or how does the findings will look like. Because until unless there is some attack which is there or there is some issues which is there, it will not be finding anything. Now it's very rare. Generally, it's very rare until your very big application is running, you will not find anything. So that's the reason they have put a sample finding. So sample findings helps you to visualize and analyze the finding types in guard duty generates. That how does the findings will look like when guard duty will be generating those findings. So let's try and check it out once. Once actually in my one of the classes, no, I was able to find a virus. So I introduced it in EC2 machine. I installed that virus in the EC2 machine, but they terminated my account. They removed my account only. And I was not able to create a new account for around 6 to 8 months. They used to terminate, suspend my account immediately. So now this is the way I'm using it to generate as a sample findings. So you also, if you find any articles, anything that says that this is a virus, you can install it on EC2. Please do not do that. So they have successfully generated some sample finding. Let's see. See. Now these are sample finding. It's not an issue with my account. Okay. This is just a sample finding for you to understand how does it look like. Now view all findings. If you click on it, you will see these are some sample findings which is there. It was able to find these problems. Let's say S3 malicious IP. See, malicious IP caller is there. Server access log was enabled. Okay. There's a Trojan. Trojan, if you have heard about it, it's a virus now. Trojan, if you have heard about it, it was a virus. It's a virus. Trojan. Trojan is a malware virus. Okay. See, is a malware that disguises itself as a legitimate program or file to gain the access of the user device. This Trojan happened in one of my project once. Okay. So I cannot recall it properly because we got it immediately. There was some software which was installed. So it started sending some random mails to the people saying that you have won this lottery. This is your winnings. Click on this. So some automated mails started going from our application. So that time, as I remember, there was a simple, nowadays we don't have such an application. We were developing a recharge website. So that's where this issue started coming up. Someone hacked that website. But nowadays the system is very secured. Okay. It is like 12 years back. 12 years, like I was also very new to the system. So it was being handled by not 12, around 14, 15 years back. Recharge websites. Nowadays, so we don't have those stuff. But yes, um, that it was being, we got that error, we identified those errors, but it was then being handled by the leadership, the upper side teams. So this was one of the issues. You can see here it is coming up. Unauthorized access to the relay. There is some unauthorized access which is there. Okay. Then there is okay. Let's see issues related to S3. Not giving anything. Okay, fine. Now, yeah, IP caller is there. See, finding, this is one of the finding which is there. It automatically generated, or this is a sample finding. And what has happened is there's an instance which is there. It has generated a finding description. Some findings was being done. Okay. And if I click on this export button, yeah, I can export it, download it, and share it with my developer. So developer will get that information. The S3 API generated finding API name was invoked from a malicious IP address. So there was a malicious IP address which is there. From this malicious IP address, someone generated the API finding. Okay. So this is attempt to adversary to tamper the data in your AWS environment. So someone is trying to access my private bucket. So this is what is happening up. We could have other stuff as well. Trojan. If you click here, yeah. The process generated a finding process name from EC2 instance. This is a sample instance. Is querying algorithmically generated domains. Such domains are commonly like it's just trying to open some domain from your EC2 machine. Okay. So yes, that's again one of the issues. And it actually divides it into three parts. One is high, medium, and low. High means it's at a risk, you need to immediately solve it. Medium is like, yeah, it can handle, you can do it in 1 or 2 days as well. Low is like, yeah, after high and medium is being solved, you can go with the lower one. But when you're working in the projects, you will see that sometimes the high issues comes up and it goes away within 2-3 hours also. That is a very possible scenarios. So you, whenever you're doing it, you just have to look at it and you feel that if there is some attacks or some issues are being coming up related to some malware activities which is being happening up, those need to be taken care of. Most of the times you will see that there is some infrastructure issues are there and it started giving some errors and it just goes away as soon as the infrastructure is being taken care of. This is a very common problem which could be there, so you have to identify it before reporting it to the manager. The first thing when you see these very high issues and it's related to some Trojan or some attacks, you have to send up a mail to your manager. Okay. And then sort it out with your manager first of all. In our company, there's a separate team which takes care of these things. We as a solution architects does not have to really worry about it. It's being completely handled by a different team. Now, if there is something which is need to be done or taken care by a solution architect or the DevOps engineer, they will get a mail. Okay. From that separate team. If I go to EC2 malware scans, I think there is no scans. So you got it right. So these are some findings which is there. And you can just work on it, check it out, these findings. You just need to go to the settings here. In the settings, you will be having, you need to generate some sample findings. Now, after this is being done, okay, you know it's for 30 days, it's free. After that, it will be charging you the amount. It's not a free service. It will be charging you the amount to check your whole account if there is some problem or there is some activity, unwanted activity which is going on. So what we can do, we can suspend it. Okay. So when you suspend the guard duty, it will no longer monitor your AWS account. It will not generate any new finding. Okay. So the existing findings will not be affected. So if you do not want to affect the existing findings which is there, then you will be going for the suspend. But when you're doing a disable, okay, you will lose your existing finding. When you suspend it, your existing findings will not be lost. Whatever output it's there. Not be lost. But when you disable it, your existing the findings which are already there will also be lost. Right now, we just have some sample findings, so we can just go for the disable button and disable it. Do not just leave it enabled, because ultimately you might end up wasting your all of your money there. Okay, so guard duty is an intelligent threat protection accounts or workload. So when you click here, you just need to click on get started and the same page will open. Okay, and the same page will open here as soon as you enable it. Right now there is zero findings, but I can generate new findings as well. I can generate the sample findings. For now, I have disabled it and simply disabled it. Any questions till this point, guys? Anyone here who was not coming from the previous classes? I think today there is more candidates. Anyone who was not coming or not joining the previous classes, guys? Okay. Okay. So, Joseph, this is our current batch only, which we are having from last, I think, 1 month. So it's the same batch. Any question till this point, guys? Any questions till this point? Okay. Now we will be taking up one more concept, which is SNS. Sorry, SQS, which is a simple queue service. It is being completely configured by your developers itself. But let me tell you how does it work. Now, what is a SQS? What do I mean by SQS, which is a simple query service? See, let's say you are working for company named YouTube. Okay. Let's say you're working for a company named YouTube, which has multiple servers working. Let's say you have one server where whenever you upload the file, it gets uploaded in the server one. I can say that. Where uploading of your videos happen. Okay. Second is server 2, where your videos are converted to executable or to runnable format. Your videos are converted to executable format or runnable format. Then we have a server 3, wherein, okay, the videos are finally uploaded and you get confirmation. And you get confirmation. So we have three servers, or in which the different task is happening. So in first, whenever you are uploading, you will upload the like you will have the website, but on the back end, whenever you are uploading any video, it is going to the server one. Okay, and then server two will, like, it's being configured by the developer only, but server two will convert the videos to some executable format, to the format where it can execute that particular video. Then we have a server three, where the finally we are going to upload the video and we get a confirmation. For us, it's a simple YouTube website only. But on the backend, there are three servers which is going on which the task is going on. From here, it might be uploaded to some S3 bucket. That is fine. I'm telling you one of the process. Okay. I'm really not very much concerned about the uploading of the video. I'm telling about the process which is going on. Now, let's say Akshat came here. Akshat wants to upload a video. So Akshat came and Akshat uploaded a video. It will be uploaded. Take some time to upload. Okay. But the problem which will come up is after this video, it is uploading, and after this video is uploaded, how the server 2 will come to know that in server 1, Akshat have uploaded a video. Like how the server 2 will come to know that Akshat have uploaded the video. How the server 2 will come to know that Akshat has uploaded a video. Tell me, guys. So here, the simple queue service will come into the picture, wherein as soon as he uploads a video, there is a queue. There is a SQS queue which is there. Okay, SQS. Whereas he does it, there's a token or there's a queue which is generated, which has all the details like user IDs there, what he has uploaded, all the details will be uploaded here. Similarly, other people are also uploading, their details will also be updated. Let's say 2, 3, 4, 5, and so on. Other people are also there, their data is also uploaded. So SQS is basically a fully managed queuing service, or in the single line, basically queue service. Okay, it's basically a fully managed queue service offered by AWS, wherein whenever the people are uploading, data is going to the queue service that this data is uploaded. Now this server 2 will check this queue service, will understand, okay, the data is uploaded here. This is uploaded, this is done. I need to take up to the next process. I need to convert to the executable format. It will convert to the executable format and it will update it in a different queue that converted to executable format, this video, converted to executable format, converted to executable format, and so on. It will update it in the second queue. And then the server 3 will pick it up. And then it will finally give you a confirmation that, okay, it is uploaded and this is confirmed. You're getting my point, right? It's something like, let's say you're working in some office and you have set up an area wherein, let's say, after your file is completed in the office, you put it in that area. Another person who has to work with that file now will take it from that area. So you don't have to go and talk to that person individually telling that my file is completed, now you take it over. There's an area which your office has created up, wherein you're putting the file, another person is taking the file from there. Similarly, that area is SQS here, where we will, like, as soon as the task is completed in one server, we will update the SQS. It will update the SQS. It is being completely managed by AWS, and it is this complete setup is done by the developer itself. You really do not have to do anything here. Then automatically my system will pick it up. The another server will pick it up. Okay, after the task is being completed here, it will update it in the second queue. Again, it is the second queue which is there. It will update it in the second queue. And after, now second server will also pick it up from the second server will also be picking the stuff up. The third server basically. And you will see finally the data is getting uploaded. And the notification would be generated. You got it, like you got the concept, yes or no? Please confirm. Are you understanding the concept, guys? Yes. Now let's see the definition also. You can write it if in your language once. This explanation you will not find it anywhere. These are very difficult languages which they use. Ernest, can you please repeat the whole cycle one last time? Okay, no problem, Ernest. See, suppose you have three servers. You're working for YouTube. Okay. You have three servers, server 1, server 2, server 3. Now, what has happened is the server 1 is used for uploading your videos. Server 2, your videos are converted to executable format. It need to be, you are uploading the video in any specific format, but it need to be converted on the format which YouTube actually use. So that is being taken care of. Okay. Then it's a server 3 which is there, which is where the YouTubes are finally uploaded. And you get the confirmation. So first of all, Akshat will go to YouTube and will upload a video. It is get uploaded in the server 1. But the problem is how the server 2 will identify that the video is uploaded. So there we use a simple queue service. So as soon as the video is uploaded, it's updated in the data is updated in the queue service. Username, everything would be there in that. Nothing to, like, everything will be AWS managed. So now it is updated in the queue service. As soon as the data is updated in the queue service, server 2 will pick it up, saying that, okay, we have a data which is updated. It will convert it here. Okay. And then it will update it to the second queue. Okay. Then it will pick it up from the second queue and update it here in the server 3, which is there. Okay. So this is the complete process which is being happening up. This is a complete process which is being happening all together here in the case study which I have used. Here I'm using a queue service which is acting as a mediator, which is telling my another server that, okay, the task is completed in the previous server, because it's really not impossible for server 2 to identify that if the videos is uploading, because a lot of people will be uploading the videos at a same point of time. How it will identify which user have uploaded that video? It is being taken care by a service known as SQS. Okay. Now, yes, it's like updating the status. Yes. Okay. So I'm deleting the screen. Now, what is SQS? SQS. SQS, it is a fully managed, message queue service No, spelling is wrong, it seems for me. Okay, messaging queuing service by AWS that enables the decoupling of components in a system by by sending storing and receiving messages between different software components. Okay, it allows the app. See, in this is a official definition. It's a queue service and a lot of stuff is there. Just in very easy language, it allows it's basically a service that will allow the applications to communicate with each other via messaging without being directly connected. Okay, in the easy language, in our language, we can write. Okay, it allows the application to communicate with each other via messages without being directly connected. Just think of it as a middleman where where one application sends a message and another application will pick it up when it is ready. Just consider it as a middleman. Consider it as a middleman where one application sends a message and another application can can later pick it up when it's ready. Ready. When it's ready. This is what the SQS will be doing. Now, please confirm if you are able to get it. The scenario, Muralidharan, just before this, I've explained the scenario. In that scenario, we will be using when we want to applicate or two microservices need to talk to each other and they are not directly connected, or if in the scenario the exact scenario which I have explained you, that's one of the case studies which I explained you. In that you can use it, right? No, it's not similar to Kafka. It's a different thing. Okay. when I say some examples, let's say, okay. So let's say when we can use it, let's say I have to do some order processing. When there's an order processing in e-commerce. Okay, so wherein customer places an order on an e-commerce website. So the website immediately send the order details to SQS queue. Backend system like payment processing, inventory management, shipment can pick up these messages from the queue and process them independently. So what happens is whenever there's an order which is being placed, order placed by a lot of customer at a point of time, it comes up here. It then updates in the SQS, where the Akshat ordered something, Ernest ordered something, Muralidharan ordered something, and it is being then picked up by different systems. Let's say that it is picked up by the payment gateways. Payment is being done, then it will be picked up by the next process. So in this way, the complete process can be created up very easily. Otherwise, just managing it might be difficult. Okay. Then if there is some batch job management that need to be done. Let's say, I will take an example. Let's say a company needs to process a large number of images or videos. Let's say a company needs to process large number of images or videos, okay, to apply some filtering, resizing. So what happens in this case? Okay, just a minute, applying filters. Let's say I want to add some filters or resizing. So each task, let's say processing a single image, is sent as a message to an SQS queue. The consumer will pick up the message one by one, process the image, and removes the messages from the queue once. So that is one thing. In our example, we have actually covered all these stuff. Okay. Now, these are some of the example which I can think of it right now. I want to send some notifications also. In that case also, I can use an SNS, wherein I want to send some notification to the users like SMS, email, push. So when an event occurs, like purchasing is being done, the application sends out, the application sends a message to the SQS queue with a notification detail. Okay. Then SNS will pick up that message from the SQS and then send a notification that your product order is being confirmed, something like that can easily be taken care of. So in this scenarios, we can use it. In the third one is a YouTube, the complete process which was happening up in the YouTube, which we had discussed, can also be considered. So these are some of the case studies which we can definitely take care of. Yes or no? Are you understanding? Please confirm. Now, so Muralidharan, again, I know that Kafka, you're asking Kafka. Kafka is also it's also a queuing service, right? It's also message queuing service. Okay, but there is actually a lot of difference between them in terms of their design, the features, use cases, and how they can handle the data. So let's say, okay, SQS is a basic querying service where one producer send a message to the queue and one more consumer can read it from the queue. Whereas Kafka is a distributed event streaming platform where producers will publish the message to the topics and then multiple consumers can subscribe to and consume the messages from the topic itself. Okay, I can give you more details about it, but the reason is I've never worked on Kafka personally, so I need to really cross check it. So this is a basic difference, which I know, but there are more difference than that. Okay. So what is the main difference between SQS and SNS? SQS is a queue service and SNS is a notification service. Notification, when I want to send an email notification to someone, then it's a, or I want to send a message notification, then I can use the SNS, simple notification service, Apurv. And SQS is simple queuing service where I will be using SQS as a queue wherein two applications, two microservices, how they will talk to each other, I can use the SQS. Wherein, let's say, after one task is done, it will update it in the SQS saying that the task is being done, which is being picked up by the next service itself. So this is what is being there. Okay. Images uploaded, one server get notification. It creates a thumbnail for another get notification, create a black white version. Another gets notified, does the other and does the same processing. Is it possible with SQS? Yes. Yes, it is possible. It depends on how you configure the service VJ. So it's absolutely possible. I hope you are understanding the concept. Please give me a quick confirmation here. We can have a break now. Just to understand if you have understood the concept. Okay, guys, welcome back. Okay, guys, welcome back. I'm sharing my screen now. Okay, so I will be going to the SQS, which is a simple queue service. Okay, now here a message queue service it is. Okay, it provides queues for high throughput system to system messaging. So let's now first let's create okay the queue. So let's create a queue. Now you will see two types of queuing service here, or two types here. The first one is okay. The first one which you will see is the standard one. Okay, and the second one which you will see is a FIFO, which is first in first out. Now what exactly is a standard? So standard basically says that at least one delivery would be there, which means each message each message is guaranteed. Each message is being guaranteed to be delivered to be delivered at least once. At least once it will be delivered. Okay. Second one is the first in first out, which means like the first message will be first executed. The message which is coming first. Now, message which is coming first will be executed first. Will be executed first, which means let's say I have a pool of messages which is there. One server is sending those messages and another server is processing. It's a consumer which is processing that server messages. Now, the problem is in the FIFO, if this message is due to any reason is not processed. So until it is being timed out, other messages will keep on waiting. And other people or other messages will keep delayed. So other than the payment gateways, we generally do not prefer using the FIFO. We generally go with the standard one only. In the standard, if due to any reason one particular message is getting delayed, other ones will be then processed. There is no strict ordering as such. They will ensure that best possible services need to be provided and the messages need to be processed properly. Okay. So for now, we will be using the standard one. This is like here you can put some name, let's say production. Okay, I can just put some name here. As I already said, we will be using standard 99.9% of the time. So only when you're working with the payment gateways and all where the data or when message is being lost, it's a very big problem. So there you can go with the FIFO. In FIFO, messages getting lost is very less. The number of messages which is getting lost is very less. Okay. Nitish. Now, you will see there is multiple things which is there. One is visibility timeout, there is a delivery delays which is there. Now, what exactly do I mean by these stuff? What exactly is the visibility timeout? What exactly is the delivery delay? Let's discuss them as well. So we have a visibility timeout, and this visibility timeout tells that after how much of time or after how many, like when a consumer receives a message or retrieves a message, let's take an example. Let's say you have this is a producer. It sends a message in a queue. Now there are multiple consumers which is consuming this message. Possible, no? There is a lot of producers also. There is a lot of consumers. So there are more than one consumer. Now this message, okay. Now this message, when it is being sent, it is being said that this message will be taken care by the consumer one. And this is consumer two. So this message will be taken by consumer one, but let's suppose this consumer one is busy right now. It is not able to take this message up for a certain duration of time. Now, what happens is if this consumer one is not able to handle this message for a certain duration of time, it will be visible to other consumers so that they can take up this message and process it. So in the visibility timeout, if I write the definition, okay, so when a consumer receives a message, okay, or retrieves the message, would be a correct word. Retrieves a message, it becomes invisible to other consumers for a specific amount of time. For a specific amount of time, which we call it as a visibility timeout. Okay. If the consumer does not delete this message in this time, it will be visible again so that other consumer can process it. So if the consumer is unable to process the message within that time duration, it would be within the time duration, it would be visible, or it will become visible to other consumers, which is there. Okay. We have something as message retention period. Now, what is a message retention period is? Message retention period is like how long the messaging system retains the message before it is automatically deleted. How much time it will try to retrieve the message. Some error is coming up in that message. For how much time it should be able to retrieve a message. So, for example, if I say, how long a messaging system retains the message before they are automatically deleted. Example, if I say for payment gateways, it's not like 100%, like it's not like in every payment gateway we are using the same numbers. It differs with the company. We generally use 60 or 120 minutes as which is like 120 minutes as a message retention period. After that, it is deleted. Okay, and we send a failure message to the person. Then we have a delivery delay. Okay, we have a delivery delay, which is there. Now, what is this delivery delay is? Delivery delay is basically, we are intentionally postponing the message delivery to the consumer after it is sent to a queue. Like we have sent a message to the queue. We want it to wait for some time for a consumer to pick it up. Okay. So what does it do? It says that here we can configure a delay for message delivery. Message delivery, which means message is being coming up. Okay. So let's say it sends a message here, but the the consumer will not be able to see this message for this delay period. Then it will be taking up this message. Okay. So, but basically here is when we should be using this delivery delay. So when we are working on some time sensitive tasks that need to be deferred, like for example, sending reminders or delay in the order processing, in those cases, we can go with the delivery delays, but not very majorly used. We generally keep it as default only 0. So these numbers are mostly used. Okay. The numbers which you see here is mostly used. Maximum message size. What is the message size of each message in a queue? What is the maximum size or what is the size of the message queue? Of message in queue. If you're putting less number, also it will not make any difference because it will auto scale. Okay. Then there is a receive message. Okay. There is a receive message wait time. Now, what is the receive message wait time is? Basically, yes, Nitish, definitely. Now, receive message wait time, it determines how long the consumer wait, okay, for a message to arrive when polling a queue. So this feature is related to the concept of long polling in SQS to improvise the efficiency and reduce the cost when consuming the message. So like receive message wait time. So it is like how long it should wait the message to come up to a particular queue. Okay. So we'll wait will to go or to come up to the queue. That is what is a receive message wait time is. Okay. So yeah, it's not a very difficult thing. You will not majorly visibility timeouts is the only thing which you might expect in your certification exam if you get any questions. But yeah, not other things. But yeah, you should know it. Please read it out once and tell me if you are able to get it. Can you explain receive wait time in detail? Receive wait time. Which one? Okay. Receive wait time is basically, see, yeah, visibility timeout is a different thing. Okay, visibility timeout is, let's say my message, whenever it comes, it is being marked that it will be taken care by this particular consumer. But if that consumer is busy, it will not be processed. Okay, it will be kept in the SQS only. Now, when SQS it is there, it after visibility timeout, it will automatically being visible to other consumer and they can use it. That's what a visibility timeout is. Now, here, receive wait time is, let's say there is a producer which creates a message. Now, it's before sending it to SQS, there's a polling activity, which means that there is a particular duration it waits before sending it to the SQS. There's a particular time it will wait before showing or before putting it to the SQS. That is what is there. Okay. You got it right? Please confirm. Working examples is not possible because there's an application configuration which need to be done. Okay. That is basically a concept which comes up either in AWS DevOps or AWS development profiles. But if you want, I can share you in the group itself, but it will take around 15-20 hours to complete it. It would be complete application deployment and then working across it, and Python knowledge would be mandatory there. Even to do the task. Okay. So yeah, this is what we have. As a solution architect, you really do not have to worry about all these stuff. I've just shown you. In delivery delay, is the sending side and receiving side wait is the receiving side. In the delivery delay, which one? Yeah, delivery delay is basically the message will come up in the queue, but it will not be taken into the consideration by the receiver, which is the basically by the consumer for a certain duration of time. Okay, that's a difference. Got it? I will just take one example. I will take some example. There's an office. Okay. There is two employees. There is a multiple employees which are there. There is a place. Okay. They work on a file. After their task is done, they put that file in this place. And other people who are the next, like they sign the files. These people create files and these people sign the files. So they have to pick these files up and sign. Now, in visibility timeout, let's say this person says that my file should be signed by this person one and send it here, put it here. That file is now here. But this person one is busy right now and this file need to be signed within 5 minutes. So now he said that, okay, in 30 seconds, if this person one is not able to pick up the file, other person can also sign it up. Now it will be available to other person and other person will come and pick it up and sign it up if that person is free. So that is visibility timeout. Okay, delivery delay. Delivery delay is like we are putting up a delay saying that this file will be kept here, okay, for a certain duration of time before this person one can even see that file is there. That is a delivery delay. Okay. Then the third one is receive message wait time. Receive message wait time is basically this file is created by this person. It will wait for a certain duration of time before putting it to SNS, because when you're putting it to SNS, you have to pay a bill. So this is this place. Whenever they put a file here, they have to pay some amount. So this person will wait before putting it here for a certain duration of time. It's like polling activity need to be done. So that's the difference between all three of them. Okay. Delivery delay is like it is not visible to this person for a certain duration. This person delays putting the file is receive message wait time. Visibility timeout, if this person one does not have time, it will be taken or used, it's being completely taken care by other consumers. Okay. Now I will be clicking on the next part. Yeah, there is one more thing which is there, which is a dead letter queue. Okay. Now, what is basically the dead letter queue is? The dead letter queue. Can you tell me what do you understand by a word dead letter queue? What do you think would be the meaning of a dead letter queue word? Bounce back. Okay. Okay. So we have a dead letter queue, which is there. What is a dead letter queue will do? A dead letter queue captures the messages. It captures the messages that can't be processed. That can't be processed successfully after certain number of retries. Retries. So that is being saved in the dead letter queue. Now this queues will actually help you in debugging and handling. This queue will help the development team, the AWS development or the development team, for handling unprocessable messages. Unprocessable messages will help the development team to handle the unprocessed messages. So the most messages which are not being processed, they will consider as a dead letter. Dead letter is that messages which are not being able to process, and we put it in a queue that we call it as a dead letter queue. As simple as that. Okay. Now, create a queue. For now, we are creating a queue here. Okay. Send and receive the messages. For now, we are sending, like, let me just send some messages and let's see. I will just send some messages here. I'm just putting it manually, but it will be configured by the developers. So I send. Okay. It will not be processed. There is no consumer right now. Second. 3, 4, 5, 6, 7, 8, around 8 messages. Now, if you come back here, you will see in the queues, there is, okay, yes, it will increase 8 messages. Okay. So now we have 8 messages available. There is no consumer. It's available to be processed. Okay. There is no consumer. There is no consumer here. No consumer. Consumer here. Okay. Then there is a message in the flight. These messages will go in the flight and then it will be consumed. We will now either we have an application, we have a developer who can just exactly configure it. It's a very easy configuration. Developer does not take much time because the complete documentations are available. This is being covered in the AWS development like professional course. The one which I'm telling you is being covered in the AWS development associate level course. Solution architect actually does not cover this part, which I'm telling you right now. But yes, but you should know about it. What I personally feel is you should be knowing about it if you are working. Now, this is what we will do. We will just go to Lambda and you will see the Lambda is there. I will just digest these messages via Lambda. Okay, I will create a function and I will just simply digest these messages. So in the blueprint, we have, I think we have the SQS messages. Yeah. Process message in the SQS queue. So an Amazon SQS trigger that logs the messages in the queue. So what we are doing is we are using Lambda, which will log the messages, which is there in the SQS queue. I will just select it. It's developed in Node.js, whatever the code is, it's being developed in the Node.js. Okay. I will create a new role itself. It will create an IAM role here. So what we are doing, we are using SQS and then we are putting up the role name. Okay. Now we have which queue we want to digest, this production queue which we have created up. This is what I want this Lambda function to consume. Now it's just consuming this message. Okay. Now the process will be defined further by the developer that, okay, after consuming, what it need to perform or which server it need to work on. That will be taken care by the developer itself. You really do not have to worry about it. So here you can just put up the SQS message. Here you will say that I want to activate the trigger and this batch size is optional. So whenever there is a message which is being coming up, automatically this Lambda will trigger and it can take up to 10 batch size. More the number, if you're putting 10,000 also, it can take up to 10,000, but the cost will increase drastically. You will see the cost will even go more than $5,000 a month, which is really huge. So you have to keep it minimal until your application is receiving a very huge number of traffic where, yes, definitely paying the amount will not be a big concern for your company. Okay. Now batch window would be 0 as optional. That's fine. And I will just create a function here. I've kept everything as default only. Now, when this function would be created up, those messages would be digested by the Lambda. Okay. Now, if I go to the SQS, create a, it's done. If I go to the monitor here, it takes actually some time to show this outputs. Yeah, it's not showing any output right now. No data. Okay, I'll go to SQS. Let's see if this is digested from here itself. See, 0 messages are now available. Okay. Now if I click on here, this is my Lambda trigger, which is being created up. Okay. And if you go to the monitoring, not being configured yet. It will take some time. Monitoring takes some time to get it configured. It will keep showing this data for half an hour or 15 minutes, and then it will start showing up the data. Okay. So when I'm sending up a message now, my system will be, my Lambda function will trigger and digest, consume this particular message automatically. See, now there is no messages available. So Lambda function is digesting that particular message, which is being created in the SQS. I hope you are getting it. Please confirm yes or no. I have this lab, same lab. Yeah, same lab is there. I will download and I will share it with you. Yes, it's for testing purpose, just to show you that my messages are being digested. Okay. What do I mean by messages are being digested? Which means that we have some messages in the queue. Lambda function is taking up those messages and consuming. It's a consuming those messages. It's a consumer. It's consuming those messages, and my developer can, like if it's some application is there, we can configure those application as well, or whatever tasks need to be performed, they can be performed easily. So what we are doing, I'm just showing you that these messages were available. Now with the Lambda, I'm just consuming those messages. That is one. Right. Understand? That's what is the whole concept, right? Right now, if you see, there are 0 messages available because they are being digested from the Lambda. Earlier there was 8. No, I've shown 8. I've created 8 messages, right? Earlier I have configured 8 messages. Let me show you again. If I delete it, this will be removed. Okay. You will see, you will able to see in the queue from here itself. Messages available is basically the messages which are there in the queue. If you see, the messages available is the messages which are available in the queue. Okay. So when I send and receive message, I will say, let's say I have message 1. This is being sent from some consumer. Okay. I will go to the queue here and you will see, yeah, right now it's in the flight because this on the backend, it would be like the consumer might not have been deleted on the backend. It would be in the deleting phase. Now it's stuck in the flight, which means it's there. Okay, it's there. It's in the process, but it's not able to find that process right now. That is what is being happening now. Okay. So this is the whole process. This is the whole process which is there. I generally do not feel that it's something you should actually really put a lot of time on. But yes, this is what is there in the SQS. This is a concept which is there in the SQS. I hope you are understanding the concept. The only concept is important in the solution architect. Okay. Now, I'm giving you some videos which you can refer. Just look at the first, second, third video on the date wise. So it covers two major topics of the DevOps profile. This is a video. Okay. I request you, please do not tell it to add Eureka. No? It's not allowed actually. So, okay, you can refer to it. It will help you out to understand the things better. Okay. I will further be sharing more details with you. This is the AWS videos if you want to refer. I have actually covered everything for you. So this is some AWS videos which is there, which I have created. I have covered everything, but yes, still if you want to refer to it as well, you can refer to it. Any questions you have, you can feel free to ask. Yeah, these are some extra notes which you want to refer, you can refer to it. So if you go to the notes here, yeah, there are some notes. Reading notes is there for you. I think I've already given you the access to it, but still I'm just giving it again. You can just have a look at it. Just open them and just check it out whether you are able to access it or not. You have to reach out to me in case you are facing any issues in the jobs also. You can reach out to me. Okay, I will let you know if there is any opening coming up for me in my company and will update you. Okay, so that is what will be definitely be there. But yes, the openings which I will be telling you will be in India. Okay, so because I don't get our US data for our company, so I majorly take care of the India entity. So I will let you know. Those who are interested can really work. We offer work from home. Okay, also. Yes. Srinivas, I've shared the material. Rest material, I will share it later on. Okay. Some material I have shared it previously. Oh, this is the material. You can open it. Rest I will share it later on. Okay. Now, okay. Thank you guys. Have a nice day. Have a wonderful day. Thank you. Bye bye. Yes, Shraddha. Thank you. Okay. I'm sorry, Shraddha. I didn't talk to you. I talked to a different person. Sorry, sorry, sorry. I thought you called me once, so I am really sorry. She was also Shraddha, but she's from another batch. Yeah, yeah. Or you were the one. I really forgot. Thank you. Thank you. Thank you. Take care, guys. Bye bye. Have a nice and wonderful day. Reach out to me in case of any kind of issues, any notes you want, anything, you can just directly ping me. I will guide you. Okay. Bye bye. Take care. Yes, yes. Today is the last class. Thank you. Thank you. Thank you. Thank you. Yes. Yes. Thank you. Today is the last class. Thank you. So, okay, anything you need, you can just ping me. I will just guide you there. LinkedIn profile. Here is the LinkedIn profile. Here is the mail. Okay. Thank you. Yes. 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 Thank you. So, thank you. Thank you. Thank you. Regarding exam and other thing stuff, you have to talk to Edureka. They will have a better, they will give you more clarity on that part, guys. Thank you. Okay. Yeah. Gosh. I don't have it actually. I will just work around it, but I really do not have it right now. The final project, no. So you have to work on that part because they have recently changed it, so I didn't got a time to actually create a work on it. Thank you. Okay. So I'm ending up the session. Thank you for your time, guys.